looking at the three probability axioms. Then we looked at some propositions that can be derived from those axioms. And we already looked at two propositions. We want to look at two more. Some propositions that can be derived from the three probability axioms that we looked at that can be derived from the probability axioms. So we looked at two propositions. Number one, that probability of E complement is 1 minus probability of E. Number two, we looked at probability of null set is equal to 0. Now I want to look at the third the first one we already looked at. I want to look at the third proposition, which is that if E is a subset of F, then probability of E is less than equal to probability of F. So when we say that E is a subset of F, now this means that if E is a subset of F, this means E is contained inside F. This means E is this what so when we're saying that E is a subset of this E is a subset of F, this means E is contained inside F. So if we illustrate this using a Venn diagram, so this is a sample space, and if we represent event F as this, if we represent event F as this, then this is event E. E is contained inside F. And this proposition says then probability of E is less than equal to probability of F. Now let's look at the last proposition we want to look at. Proposition number 4. Proposition number 4 says that probability of E union F is probability of E plus probability of F minus probability of E intersection F. Now, if you notice, this is that axiom number 3 also talked about probability of union of two events. But when we looked at probability axiom 3, that talked about the probability of union of two events that are mutually exclusive. Here, E and F are not necessarily mutually exclusive. This is how it's different from the axiom. When we looked at the probability axiom number 3, it was talking about the union of mutually exclusive events. Here, E and F are not necessarily mutually exclusive. So they don't necessarily have to be mutually exclusive. This is so here basically probability of EF is just the probability of intersection of E and F. Like we talked about, we can write the probability of intersection of two events either using the inverted U sign, or we can write it without an intersection sign as well. So this is a probability of intersection of E and F, which you can write with the inverted U sign or without the inverted U sign as well. Right, so we subtract this to eliminate double counting of intersection part. Double counting of intersection part. So this is why we need to subtract this, because if you look at these two, right, this is E, this is F, right? If these are two events and they're not necessarily mutually exclusive, so they can have common outcomes, this is the common part between them. So in that case, if we were just to add the probability of E plus probability of F, then we'd add the intersection part twice. So that's why we subtract it once to eliminate double counting. Now, if E and F are mutually exclusive, if it turns out they are mutually exclusive, then we know are mutually exclusive, i.e., you know what does mutually exclusive mean? So probability of the intersection is 0, right? Why? Because mutually exclusive events are those such that the intersection is the null set, and probability of null set is 0. This is essentially probability of null set. Because if they are mutually exclusive events, then the intersection is the null set, and we know probability of null set is 0. Right? Then in that case, we know probability of E union F will just be probability of E plus probability of F, which is what axiom 3 is, right? So basically, this is what we call the inclusion-exclusion principle. So this is called the inclusion-exclusion principle, or addition rule of probability, or addition rule of probability. Right, so this generalizes union of two events that are not mutually exclusive, right? This generalizes, so this essentially generalizes union of two events that are not mutually exclusive. Because we know for mutually exclusive, so if for in general the probability of union of two events can be found using the inclusion exclusion principle, or what we call addition Euler probability. So it's the probability of E plus probability of F minus probability of the intersection F. If E and F are mutually exclusive events, then we know the intersection is the null set, and so probability of their intersection, which is the null set, is just going to be 0. So in that case, this just brings us back to axiom 3, where probability of E union F is just the sum of the individual probabilities. So if you have mutually exclusive events, the probability of union can be found using axiom 3. But in general, for any events that may not necessarily be mutually exclusive, we can use this proposition to find the probability of their union. Now, we can extend this to 3 events as well, and so on, right? So we can, right now we talked about how to find the probability of union of 2 events. We can extend this to 3 events and more as well. So we can extend this, right, and more as well. So say we wanted the probability of union of 3 events, probability of E union F union G. So for this, what we do is we add the individual probabilities one at a time. Sorry. So we do this probability of E plus F plus probability of G. And then what we do is we subtract the intersections, probability EF minus probability EG minus probability FG. And then we add back the intersection between all three, E, F, G. So what we're doing over here is, in the case of 3 events, if we're applying inclusion exclusion principle, we're taking single events, we're adding their probabilities. We're taking 2 events at a time and subtracting the intersection, 2 events at a time. And then we're taking 3 events at a time and adding the intersection back. So in general, so what we're doing over here is we add individual probabilities, So you add individual probabilities, then subtract all possible, intersection of 2 events, and then add intersection of all 3 events. In general, if you want to generalize this even more, we looked at for three events, you add the individual probabilities, then subtract the intersection of all possible intersection 2 events, and add intersection of all 3 events. So in general, if there are more than 3 events, in general, probability of union of events equals sum of probabilities taken one at a time, sum of probabilities taken one at a time minus probabilities taken 2 at a time plus probabilities taken 3 at a time, and so on. So this is a general pattern that for the inclusion exclusion principle when you have more than 2 events, right? So you take the probability of union of any number of events is equal to the sum of the probabilities taken 1 at a time minus the probabilities taken 2 at a time plus probabilities taken 3 at a time, then minus probabilities taken 4 at a time, and then plus probabilities taken 5 at a time, and so on.